Hello. Is it starting? Welcome back to math. This is Tuesday, I think. We're working only on two problems today, 48 and 49. So we're going to be using the data from the temperature for the climate change problems from earlier on in this section. And we're going to look at the box plots and see if we can tell if there's a difference between 1975 and 2000. So by looking at your the first question right here, A, by looking at your box plots from problems 846 and 847, determine which year of temperature data has the greatest range. So the very first one, 1975, was the one that they showed you? Yes. And then 2000, you were supposed to make up on your own, I believe. So I have them right here in my handy dandy whiteboard, of which, let's see if we can move this big butt out of the way. Okay, so the top one, hopefully you can see it a little closer. This top one is 1975. And we have the median, which is 63 degrees. And then in 2000, our median is a little bit higher. It's 65 degrees, so it's warmer. By smidge. What do you think, Pissy? Is that enough? Do you think that's enough? I don't know. Okay, it's a little bit higher. Then we have our outlier here in 1975, the lowest in Alaska, which is 13. And then the lowest jumps way, way warmer on the same day in the same city 25 years later. So that definitely could be a significant number to talk about global warming. And then we have 84 and 86, a little bit higher for the highest in Hawaii. And then this is the first quartile of each of these, 56 being the number here. That's the median of this quartile. And 54 is the median for this quartile. So this is cooler than that. So older is a little bit warmer. And then this is a little tiny bit warmer. So you're supposed to look at those and decide what you think about the differences in temperature. So let's go back to, oh, no, it's still on there. So 48 says, look at the box plots, determine which year the temperature data has the greatest range. Range being the difference between the lowest and the highest. So hopefully that's obvious to you. It is 1975. In addition, B says, in addition to range and mean absolute deviation, there is another way to calculate spread. The interquartile range is found by calculating the difference between the third quartile and the first quartile. It is the range of the middle 50% of the data. So it's kind of talking about a central tendency, not talking about the fringes at all, just looking in the middle 50%. So you're going to calculate the interquartile range for the temperature from 1975. And you should be subtracting this number and this number to get that. Calculate the interquartile range for the temperature data from 2000. So you'll be calculating the difference between this number. No. I know it's a little confusing, but fun fact, my daughter is taking statistics right now in college, and they are literally talking about interquartile range right now. It's pretty cool. Now, which year of temperature data seems to have the most spread measured with the IQR? They're calling the interquartile range the IQR. So one of them is going to be a teeny bit bigger than the other one. And what advantages are there in using the interquartile range to measure spread instead of range or instead of mean absolute deviation? So the range has that outlier. So that's the big reason you don't want to use the range. So you can answer that kind of in your own words. And then 49 said, we're not doing 50. 49 says, look at the histograms and box plots of temperatures the class created, which you could see in that on this board. Well, we don't really have a histogram on that board, do we? Compare the shape, center shape, spread, and outliers for both data sets. According to these histograms, what can you say about the temperatures? We didn't have histograms anywhere, did we? What the book showed you? No. Wonder if I have the histograms in my notes. No, I do not. Okay, so I guess you're going to have to do your best on that. Maybe you can find that in the previous video. Bummer. Do the graphs. So looking at just the box plot graph, don't worry about the histogram. Do you think that this box plot shows, these two show that one of the years is warmer than the other, or are the temperatures basically the same? Be prepared to share your reasoning. That's the most important thing about looking at statistics. Share your reasoning of why you think. Okay, and then there's a couple of homeworks, 3 homeworks. And the last one is, how do you call it? Checkpoint. So you have to do that one and make sure you know that to go on to 7th grade math. And you can check your answers here by clicking that link. Checkpoint 8A. So make extra sure. I'm glad we have a lot of time on this lesson in 3 days. So you can focus on the distributive property here in that last question. 3 outside multiplies the 2, and then it also multiplies the x. So this ends up being 6 plus 3x. So I will be on office hours, say 11 to 12. If you have any questions about the math or the science, or you just want to say hi and say hi to my dogs and tell me how you're doing, let me know if you need anything, or, you know, how are you feeling? I'm sure you're feeling kind of lonely. I love you guys. Peace out.